Hey folks, my name's Craig Otto. I'm a Lean Six Sigma Master Black Belt. Thanks for joining me today. Today we're going to continue on the Yellow Belt series that I've been doing. This is the fourth video. It's called Video 2 Follow-Up. The way that I do my videos is through instructional videos first, and then I do with hands-on second. So as I mentioned, this is the fourth video, so I've had two hands-on videos so far. One follow-up video where it's hands-on with what happens to be a Lego exercise. And this will be the second follow-up video, which is also hands-on. Please also, I recommend checking out www.ottoopx.com. You'll see more training programs on there, as well as my blog and forums. So I encourage you to check those out as well. So with that, we're going to go ahead and get started on the follow-up to our original Yellow Belt training part 2, which was about implementing 6S and also spaghetti diagrams. And so we're going to learn about this tool of 6S and spaghetti diagrams through this Lego truck factory exercise. So I have a little Lego truck that we build, and what we're doing is capturing some of the things that we see with the process, and then we'll make the improvements in this video using the tool of 6S and spaghetti diagram, and I'll also capture the metrics that improve with that so we can see what tool impacts the metrics the most. And I have several trials that we're going to do. This one happens to be 6S and 6S and spaghetti diagram. The next one that we do, the next trial, hands-on learning, will be one piece flow, and then the one after that is full systems, and one after that is standard follow-up. So each iteration through the Lego truck factory, we'll be able to see how those tools impact the overall productivity of the factory. All right, and as mentioned last time, we talked about the 6S implementation. Sort being the first S, and again, order always matters. Sort is where you drive down the amount of space that you use because you're getting rid of what you don't need. And again, distance is the enemy when it comes to your work. And with that, once you sort things out, you can straighten, reduce that distance even further. And really what these two items are doing is reducing the waste of motion. Shine, again, is about making the organization speak to you visibly. It's about that ability to mentally connect and see problems faster, as well as do the job faster, because the organization is speaking to you because of this Shine tool. Then, of course, safety. In all things that we do, we need to be safe. And those four together are things that should be done on a daily basis. And we monitor that with routine of standardize, making sure that we have these four first S's repeated regularly to counteract the second law of thermodynamics, which says that everything will get worse over time. So that means that you constantly need to be putting energy back into the system in order to maintain what you have. And that's why we repeat this process over and over. And of course, last but not least, is your sustain. That's establishing that external source to kind of monitor and ensure that you have that cadence of accountability to get this tool done and used and implemented. All right, now we can see our A3. We had started this in a few of the training sessions before. As you go through the process, you'll be filling out this A3 as we go. Some of the things we're going to be looking at this time is that spaghetti diagram, as well as getting into implementing the 4 core tools of lean manufacturing, which is 6S, one-piece flow, pull systems, and standard work. Particularly today, we're going to focus on 6S, as well as that spaghetti diagram. And so with that, the first thing, when you start to go into a rapid improvement event, you want to look at the biggest bang of the buck first. And in our Lego factory, one of the things that you may or may not have seen was that these stations are very far apart in terms of the way that they're built. So each station builds 5 trucks, and then they pass it on to the next station to continue the truck build. And each station has 5, and each station you have to move these 5 vehicles quite a distance. And so one of the ways that we show that distance and that waste of transportation is by showing the spaghetti diagram like we see here. And of course, our goal is to reduce that distance because that's what actually improves the time that it takes. All right, so here you can see we move the stations closer. We'll do that in the Lego truck factory as well. This will ensure that that transportation distance is reduced. Yes, we still have 5 in whip, in our build whip, but we'll get to that once we use some other lean tools. But for this particular effort, we're only using that spaghetti diagram to get the stations closer. And another thing that we're going to be doing is looking at making sure that we process this very consistently, and we use the sort and straighten tool. You'll see in the videos when we show you the rapid improvement event, you'll see a lot of reduced motion because of the way we lay out the parts. All right, so last time we did have current state review, and I'm only showing this for just a refresher. So we had 4 different stations operating. Each station would build 5 parts, as you can see. Some of the things that we noticed is the parts are not organized, they're just tossed in a bag, and then you have to search for all the parts. The build sequence, you'll notice, isn't the same every time. You'll notice a lot of imbalance of work. Some stations get done a lot faster than others. And, of course, with the 5 whip, you have to build 5 before you can move it. That also creates a lot of trouble. So we're going to start tackling some of these issues one by one. So we talk about the build sequence not being the same every time. So really the biggest thing we need to do is make that consistent. And one of the ways that you can do that is by organizing the parts. And so when you organize the parts, let's just take a look at station 1 in the top left. You can see the sequence of build will work from left to right. And so the operator in that rapid improvement event is basically getting all the parts set up so that everything works from left to right. It's organized. Station 2, same thing. You can see there's more parts. You can see there's a lot of space that it does take to make sure it's laid out well. But that's sort of, we'll fix some of that space with some of the later tools that we implement with pull systems. But just some noticeable things, right? You're trying to make all the parts closer. You go down to station 3. You see the same thing there. Just getting everything laid out in the sequence of build. And then, of course, station 4, a lot of parts there, especially with the wheels. Very sophisticated type of build to do that. But the bottom line is, of all these rapid improvement events, we're laying things out in an organization manner that we're working from left to right. That creates a very repeatable sequence. This should help our quality issues significantly, as well as our waste of motion. You'll see a lot of reduced motion waste because we're able to set this up properly. All right, so with that, we're going to go ahead and get started on trial 2, and this will show us results of how does 6S impact the performance of our Lego factory. So first of all, you can see the parts are much more organized. If you just watch the hands in general on all the stations, the hands aren't moving a lot, right? It's just following the sequence. The hands aren't moving a lot, whereas before they were digging through looking for parts and whatnot. And so this is a big deal. This should help save a lot of time and make this more efficient and so forth. It does take, in terms of the space, it is less space, but it's a little bit more organized and better use of that space. And I think once we use some of the other tools, we'll be able to even further reduce the amount of space that we need. You can see the time is still a little bit more imbalanced. Station 4, it's a little bit more noticeable now compared to last time. That Station 4 does take quite a long time, and that'll end up being a big deal as we go trying to get further results. But overall, this seems to be much better in terms of efficiency, and especially with quality seems to be much better as well. So I think we'll see a much better profitability in our Lego factory. So with that, we can go ahead and see the results. As mentioned, the first bar will be what the original current state was. And then you can see the little blue recycling thing there at the bottom of each chart. That represents the 6S tool. So you can see how that 6S tool impacted the metric. The little river there represents one-piece flow. The magnet is pull systems. And then the last one, the paper with the return symbol is the green return symbol is standard work. So each time you're going to be able to see how each of these tools systematically eliminate waste and improve performance. So overall, you can see quality is much better. We had 2 issues in Station 3 where we wasn't able to put on the black suspension parts. So that was our 2 quality issues. In terms of whip, still pretty much the same amount of whip. 6S didn't really do anything to impact the whip. Space, it was reduced. Mainly because of the spaghetti diagram tool. not necessarily the 6S tool, even though 6S can help with space. It was more the what I would say the spaghetti diagram. Output, our throughput, we went from 5 to 8, so obviously that's good. That's almost doubling our output. Efficiency as well, going from 3 to 8, that's almost doubling our productivity. And our lead time, since the whip didn't change, our lead time was, for all intents and purposes, pretty much the same. It did show a little bit improvement. The batch size, again, we're building with 5, so that did not change. But you see in terms of profitability, a very significant improvement. We were at negative 209 last time for a loss of 209. This time it was only a loss of 3. So that significantly improved our profitability just with the 6S tool. And we'll see a lot of what's costing us right now is the amount of whip we have on hand. So that's really why we're not profitable. So we'll see as we go, some of these other tools will definitely help impact that. And here we can just kind of, what I'm going to do is track each of the results of each tool as we go and how it impacts the metrics. And then at the end of all of this, we'll be able to see what impact this business had by using all of these tools, and why it's so important, how powerful it is. And then, of course, we always want to document this type of activity on our A3. For today, we did our rapid experiments, our rapid improvement event. We implemented 6S into our value stream. As we go, we'll keep adding to our A3. So with that, we'll go ahead and summarize everything that we've learned today from our rapid improvement event and incorporating 6S. The first thing is that 6S does have a significant impact on reducing the waste of motion. So motion is the waste that is the thing that most operators have within their control. And so that's very important that you're able to act on that. The other thing that it did, what reducing motion does, is it helps quality so that you can repeat things consistently. It helped our output, right, our delivery. We're able to produce a lot more, which there in turn helps our efficiency and as well as our profitability. So you can see some of the impact that 6S had on those. Some of the things that 6S did not impact, it didn't really help our whip or our lead time or batch size. Those are different tools. As mentioned, it didn't impact the space a lot. So there's other tools that we'll use to impact things like that. The spaghetti diagram, so that was the other tool we used in the very beginning. That had a significant impact on reducing the waste of transportation. So initially, these stations were very far apart, so we had to transport the material from one station to the next. And so by using the spaghetti diagram, we were able to see that and reduce the waste of transportation. It made everything much closer. Here with the spaghetti diagram, you can see that impacted space. It also impacted our efficiency and our delivery, our output, and our profitability. So two very powerful tools here. Some of the things that spaghetti diagram did not impact, not so much on quality, didn't really impact the whip or the lead time or the batch size. In reality, sometimes if the product is really far away to the point that we're talking days, then it could impact lead time. But for the most part, if you're just talking about within your plant, it should not have a huge impact on lead time or the whip. All right, so that will conclude our video 2 follow-up, demonstrating how 6S and spaghetti diagram help your business and reduce the amount of waste in your process. Looking forward to next time. Next time we're going to get into video 3, which is about one-piece flow. That is a hot topic a lot of times with production supervisors. Many times production does not like one-piece flow, and so there's reasons for that, and I'm going to get deep into that in our next video 3. So looking forward to that. Once again, thank you for following this video. Please subscribe, like the video. Check out my website, www.ottoopx.com. When you do that, it helps grow the ability of my videos to get out there, and so other people can see and learn from it. So I'm looking forward to the next time we get to meet. And thank you, and we'll see you next time.